Okay, good morning, everyone. On the hour here, so I think we're going to get started. I'm Becca from the Media Relations Office, and along with my colleague Liza, I'll be helping to run this press conference. Our first press conference of the day will be the much anticipated NOAA's 2021 report card. We will begin with panelists each giving brief presentations describing their work, and then we will open it up to questions from reporters. We will end the session at 10:45 a.m. This is an extended Q&A session, or when there are no more questions, whichever comes first. Reporters, because this is a Zoom webinar, you won't be able to turn on your video or microphone. So in order to ask questions, we are using the Q&A box. So if you go into the Q&A box, you can type your full name and affiliation, and we will request that you unmic to ask your question in the order that your requests were received. Alternatively, if you would rather just type out your question along with your name and affiliation, we are happy to pose your question to the panelists on your behalf. You can write in your question at any time, but note that we won't ask it until the panelists have finished their presentations and we are in the actual Q&A session. Please make sure that your Zoom name is accurate so that we can quickly find you in the participant list. The slides and additional materials related to this press conference will be posted to the Press Information Exchange on AGU Connect, and we'll drop a link to that in the chat. It's also being recorded, and that recording will be shared to AGU's YouTube channel, and we'll link to that in the Press Information Exchange as well. Should there be any technical issues, please bear with us. If Zoom webinar goes down for some reason, we will switch to presenting this press conference using a teleconference line. If that happens, we will immediately send an email to all the panelists and attendees with information on how to connect to that teleconference line. If you have any technical issues during this press conference, please email news@agu.org. And with that, I will turn it over to the panelists.
Thank you, Rebecca. So good morning. I'm Rick Spinrad, the NOAA administrator, and it really is a pleasure for me to welcome you all to what is an annual seminal event, the 2021 Arctic Report Card Press Conference. The Arctic Report Card is an annual volume of original peer-reviewed environmental observations and analyses intended to document the rapid and dramatic shifts in weather, climate, terrestrial, and oceanic conditions in the circumpolar north. This is the 16th Arctic Report Card produced by 111 scientists from 12 nations. Over the years, the AGU has been a wonderful host for our press conference, and we're pleased to be releasing it here today at the American Geophysical Union during its fall meeting in New Orleans. While I am not an Arctic scientist, I can say that I've had the opportunity to spend time in the dead of winter at NOAA's Baroatmospheric Baseline Observatory located in Ikaaġun. So I want to offer congratulations to the Global Monitoring Lab and the community of Ikaaġun for completing the renovation of this critically important climate research station into a state-of-the-art scientific facility last year. This past August, a new IPCC report based on research by the top US and international climate scientists found that human influence is unequivocally causing climate change. It confirms the impacts are widespread and rapidly intensifying. This is especially true in the Arctic, where intense scientific study across a variety of disciplines and indigenous knowledge has detailed a similarly unambiguous story. Climate change is unleashing a disruptive cascade of interrelated stresses and impacts with environmental, economic, and national security implications that extend far beyond the Arctic. While no new blockbuster records will be recounted in this year's Arctic Report Card, it continues to show how human-caused climate change is propelling the Arctic into a dramatically different state than it was in just a few decades ago. The trends are consistent, alarming, and undeniable. Rapid and pronounced warming continues to drive the evolution of the Arctic environment. From this year's report card, we learn that the October to December 2020 period was the warmest Arctic autumn on record dating back to 1900. The average surface air temperature over the Arctic this past year was the 7th warmest on record. The Arctic continues to warm more than twice as fast as the rest of the globe. Sea ice extent is especially important to track because ice reflects sunlight, preventing surface warming, while low sea ice areas allow more direct solar heating of the exposed surface water. The volume of post-winter sea ice in the Arctic Ocean in April 2021 was the lowest on record, dating to 2010. Summer minimum sea ice extent in September of 2021 was the 12th lowest minimum on record. All 15 of the lowest minimum extents have all occurred in the last 15 years. The loss of the great white cap that once covered the top of the world is one of the most iconic indicators of climate change. This report card continues to show how new threats are emerging, highlighting the uncertain breadth of environmental change that is to come. Significantly more marine debris and garbage than usual fouled beaches along the Bering Strait in the summer of 2020. More fishing nets, plastics, garbage, and hazardous materials are being lost or illegally discarded into seas that once saw very limited marine traffic. On land, retreating glaciers and thawing permafrost are causing hazards ranging from crumbling homes and infrastructure to extraordinarily dangerous geological events. The long-term observations for Eurasian and North American Arctic river discharges demonstrate an upward trend, providing evidence for the intensification of the Arctic hydrologic cycle. While some have perhaps optimistically referred to this period of cascading disruptions as a new normal, rapid change occurring across most parts of the Arctic environmental system show no signs of slowing down. The reality is that the Arctic of today is on a trajectory to an uncertain future. More than 1 million indigenous people inhabit the circumpolar Arctic. The word hardy only begins to describe the character of the many different tribes and cultures, which have not only had to survive some of the harshest conditions anywhere on Earth, but have thrived for thousands of years, relying on lifeways honed by millennia of close observation of weather, ice conditions, and food availability, stewardship of their environments, and a deeply ingrained ethic of community support and resilience. The Arctic Report Card recently began to actively seek the input and perspectives of these first peoples who are most immediately impacted by climate change. Climate change is just one of the burdens that globalization has visited on this region. In 2020, health and safety measures designed to protect vulnerable communities from the coronavirus pandemic created bottlenecks in the food sharing systems that distribute the fruits of sustenance, harvesting, and traditional foods gathered across the vast region. Communities rallied by augmenting traditional food sharing networks and developing alternative distribution methods like food drop-offs, pickups, and care packages sent to distant relatives to provision their neighbors, elders, and those without a harvester in their family. The chapter documenting their resilience is one of the bright spots in this year's report card. Humanity has never known a world where the northern regions of the planet were not crowned with polar ice. The Arctic is Earth's air conditioner. Billions of people rely on its moderating influence on climate. We have a narrow window of time to avoid very costly, deadly, and irreversible future climate impacts. NOAA, working with our partners, will also use the knowledge and new insights gained from our scientific research to support communities, including those in the Arctic, to prepare for, respond to, and adapt to climate change. I'm proud of the role that NOAA's science and scientists, analysis, and expertise is playing in helping us to confront the climate crisis. Now, before I hand off the microphone to Dr. Moon for the presentation of the 2021 Arctic Report Card, I believe we have a short video to kick it off.
The Arctic, an ancient ecosystem, is disappearing before our eyes. Disruptive heat-related impacts driven by unrelenting human-caused climate change are happening throughout the polar north. In Siberia, unusually warm air temperatures led to early snow and sea ice melt, followed by another active wildfire season. Rain was seen for the first time on the 10,000-foot summit of the Greenland ice cap. Destructive geological forces unleashed by thawing permafrost and melting land ice are an increasing threat to the homes and livelihoods of Arctic residents. These changes are not isolated. each one can have a cascading effect, some amplifying warming and further accelerating climate change. Arctic sea ice has been in a decades-long decline. Older, thicker sea ice that once covered the central Arctic Ocean is now almost entirely gone. This has enabled shipping and other industrial activities to push deeper into the Arctic year-round, resulting in more pollution and more noise in the ocean. During winter in the Bering Sea, the vocalizations marine mammals use to hunt and communicate create an almost rainforest-like soundscape. Shipping noise can drown out these calls, potentially driving marine mammals away from their preferred habitat and raising concern for the food security of indigenous hunters and their families. Increased shipping in the Arctic is leading to more fishing nets, plastics, garbage, and hazardous materials lost or illegally discarded into the ocean. Alaska Native communities reported many miles of their once pristine beaches and harvesting sites fouled by garbage. The Arctic is becoming greener. Tundra vegetation is flourishing, and shrubs and small trees are spreading into new territory. Iconic Arctic animals are losing habitat, while new species are moving in and changing ecosystems. In Alaska, exploding beaver populations are transforming the tundra. More than 12,000 dams are clogging streams, flooding surrounding terrain, and facilitating the invasion of more new species. New ponds cause underlying permafrost to thaw and release more greenhouse gases to the atmosphere. Thawing of permafrost and melting glacial ice also creates special hazards for northern residents, ranging from crumbling homes and infrastructure to extraordinarily dangerous geological events like glacial outburst floods and avalanche-triggered tsunamis. With continued warming, identifying and assessing these hazards is just one of many urgent tasks facing Arctic scientists today. All these disruptions are the direct results of a climate straining under the heat-trapping burden of greenhouse gas pollution. The time to face this monumental challenge is now.
Thank you, Dr. Spinrad, for your opening comments. And thank you also to the video and communications team for making that beautiful and heart-hitting video, highlighting some of the important topics in this year's Arctic Report Card. I'm Twila Moon. I'm the Deputy Lead Scientist at the National Snow and Ice Data Center at the University of Colorado Boulder, and I'm one of the 3 lead editors for the 2021 Arctic Report Card. My fellow editors are Matthew Druckenmiller, also at the National Snow and Ice Data Center, and Rick Toman at the University of Alaska Fairbanks. Thank you so much to both of them for their dedication and hard work. Advance to that next slide, please. The Arctic Report Card is now in its 16th year. Our goal continues to be bringing you the latest on what is happening in the Arctic physical environment by covering 7 vital signs: surface air temperature, snow cover, the Greenland ice sheet, sea ice, sea surface temperature, ocean primary productivity, and tundra vegetation greenness. Every year, we also include several indicator topics. This year, revisiting Arctic river discharge and ocean acidification, as well as a contribution on expanding beaver populations. And our annual frostbites highlight recent and emerging topics. This year's topics connect closely with the people and communities of the Arctic, examining changes in the broad Arctic marine soundscape, where we see increased marine noise from natural sources as sea ice disappears and from human sources as industry and shipping expand north. The report also looks at worrisome marine debris events in the Bering Strait, and you will hear more within this press conference on the increasing glacier and permafrost hazards that threaten infrastructure and lives, and on issues of food access for Native Alaskans during the COVID-19 pandemic. Collectively, these updates depend on the remarkable work of 111 contributing authors from 12 countries. In fact, the science and observations in the Arctic report card reflect hundreds of years of collective scientific knowledge, with most authors dedicating their careers to understanding the Arctic and returning year after year to contribute their findings to the report. In recent years, we are also working on paths to include more perspectives directly from Arctic residents, including indigenous knowledge holders, so that the report card might reflect the shared insights of people who have been living in the Arctic since time immemorial. The Arctic report card brings to the public and decision makers a unique multidisciplinary report that represents a cross-agency and international effort. We are in debt to these contributors, and thank you to all authors for ensuring that we are able to bring these important topics to the public, decision makers, and fellow scientists. This is my first year as an Arctic report card lead editor, and working to bring together this year's topics has been fascinating and sobering. Next slide there. Arctic surface air temperature measurements continue to show the Arctic overall warming at more than twice the rate of the globe on average, with even stronger warming over some seasons and recent time periods. This means that the flora, fauna, and peoples of the Arctic continue to experience rapid and often dramatic changes. However, to think of the changes in the Arctic as only warming events is to oversimplify both how the physical system works and the lived local experiences. Instead, complex, often cascading interactions form the local and regional patterns of this quickly changing Arctic. As our editorial team reflected on this year's report, several important themes stood out. We discussed these in the executive summary, which is also paired with a visual highlight map covering some of the notable 2021 Arctic events. Next slide. To start, many Arctic observations demonstrate substantial variability, sometimes making local or year-to-year predictions challenging. Next. For example, while pan-Arctic tundra greenness continues to be exceptionally high, local conditions and extreme events also caused instances of unusual tundra browning, such as in East Siberia. We'll hear more shortly about the vegetation observations from Dr. Lawrence Mudryk, a scientist with Environment and Climate Change Canada and lead author of The Vital Sign on Snow. Along with this type of location-to-location variability, we also see significant variability over time and season to season. Next highlight. For an example, we might look to Arctic river discharge, with records beginning in the 1930s for Eurasia and 1970s for North America. These long-term river discharge observations show an increase in how much water is traveling through Arctic river systems. But this big picture metric can mask important variations over short time periods. Recall that the river discharge data in the report recovers several recent years in detail. In 2020, the month of May saw an extraordinarily high discharge, followed by an extraordinarily low discharge in June. Local communities and planners cannot only pay attention to the long-term trends, they must also be aware of the quick and sometimes large swings that we now experience. One way these variations can be experienced is as extreme events. Across the Arctic, extreme events continue to break records, highlighting the challenges and preparation needed for successful adaptation. Some of these extreme events are clear within the physical system essays of the Arctic Report Card. We can look at the Greenland ice sheet, for example, an area of my own scientific focus. Next highlight. Sadly, the year after year ice loss that began in Greenland in 1998 has continued with further ice loss in 2021. Thankfully, this was not a year of extreme overall ice loss for Greenland. Yet, several extreme events still brought unprecedented conditions to the ice sheet. During the summer, the ice sheet experienced 3 separate large melt events. This was only the second time on record that the ice sheet experienced melt across more than half of its surface twice within a single summer. And for scientists working at the summit of Greenland, more than 10,000 feet above sea level, this August was the very first time rain was directly observed in this location, which should experience cold, frozen snow. Unfortunately, these extreme events have the potential to make the ice sheet more vulnerable to melt in the future. And this may not be uncommon across different types of extreme events. Having the physical system experience this new record condition feeds into the future likelihood of those conditions being experienced again. And as humans continue to force further warming of the Earth, these extremes are likely to reach new values as yet not experienced by our communities. Other extreme events relate to human activities. Next highlight. For example, the significant marine garbage event dealt with by the local Bering Strait residents throughout the summer and early fall of 2020 brought a new and extreme level of coastal pollution to this region. These physical and human system extreme events share at least one characteristic, that without direct human action and intervention, we can expect more of them into the future. Along with high variability in more extreme events, we also see clearly across the report card the interconnected behavior of the Arctic system and how this facilitates cascading disruptions. Next highlight. For instance, early sea ice loss in the Laptev Sea created an early open ocean surface that was then affected later in the summer by particularly warm sea surface temperatures. Next highlight. And we'll hear more in a moment from Dr. Gabriel Wolken, scientist and manager of the Climate and Cryosphere Hazards Program at the Alaska Department of Geology and Geophysical Surveys, and lead author of the Glacier and Permafrost Hazards Frostbite, which discusses the cascading hazards caused by melting glaciers and thawing ground, which threatens buildings, roads, and lives. Next slide. The story of the Arctic today is a human story, and this year's report helps to illuminate the interconnections across environment, people, plants, animals, as well as connections that link elements like environmental management, international policies, industry, and food access, which we'll hear more about from Kaare Sikuaq Erickson, an Alaska native and principal consultant for Ikaaġun engagement. Observations that span from the vast open ocean to the populated Arctic tundra, from coastal beaches to high mountains, show clearly that climate change has already arrived in the Arctic and created an environment that is fundamentally different than that experienced by our parents and many generations before them. And even an environment fundamentally different from that experienced by our own earlier selves. In my own experience studying the Greenland ice sheet over the last 2 decades, the ice sheet I see today is decidedly smaller than the one I discovered with enthusiasm as a student. The ice edge has pulled back, the speed of ice motion is altered, the character of the surface has changed. And I read about the effects of these changes via coastal erosion in California, unprecedented flooding in New Orleans, and rising seas around the globe. The global reach of Arctic change is undeniable. And yet, this transformation of the Arctic is not complete. We cannot rest our hat on what we observe today. Instead, environmental change will continue for many decades to come, though the speed and magnitude of some of those changes we cannot yet fully know because they depend on political, business, and public actions. The future of the Arctic depends on human actions. By bringing current Arctic perspectives and observations together into a single report, the 2021 Arctic Report Card serves as a valuable multi-perspective reference for understanding the stunning changes occurring in the Arctic, the implications both within the Arctic and far afield, and the resilience required from Arctic residents to adapt to current and coming changes. Thanks to all of you for covering these critical topics. Before I pass the mic to Lawrence Mudryk, I'd like to again thank all of the contributors who make the Arctic Report Card happen. Thank you also to David Allen, Program Manager, and Benjamin DeAngelo, the NOAA Federal Advisor for the report, and an especially large thank you to Kelly Ulig, the NOAA Coordinating Editor, whose work is vitally important for keeping all of the elements of the report production connected and moving forward to bring such a valuable collection of products to all of you. I'll now pass the mic to Lawrence Mudryk for a closer look at Arctic snow, sea ice, and vegetation.
Thank you, Twila. Hello to everyone in the press room and viewing online. I'm a scientist at Environment and Climate Change Canada, a department of the Canadian federal government, and I've had the opportunity to contribute to the Arctic Report Card since 2014. As Twila said, today I'm going to highlight some of the Arctic sea ice, terrestrial snow, and vegetation conditions that were detailed in this year's report. So in the past, record lows in sea ice extent have dominated headline statements, and for good reason. Sea ice's high reflectivity plays an important role in regulating the amount of sunlight that enters the Arctic region, and thereby helps to regulate its temperature. As sea ice disappears, the underlying ocean surface is exposed, and this much darker ocean surface will absorb sunlight and thereby allow a lot more heat to enter the Arctic system. Scientists keep track of how much of the ocean is covered with sea ice by measuring the ice extent in millions of square kilometers. As you might imagine, more of the Arctic Ocean is covered with sea ice in winter, and each year during summer, warm temperatures melt some of the ice, such that the ice extent reaches a minimum value in September, just before it gets cold enough for ice growth to occur again. The blue line on the graph on the left shows what this minimum amount of ice cover was in September each year since 1979. Despite some year-to-year variability, there has been a clear reduction in the minimum ice extent over the past 43 years. While the minimum ice extent in summer of 2021 was less extreme than the previous years, the lowest minimum ice extents have all occurred in the past 15 years. Put another way, in those 15 years, the minimum ice extent has never recovered to the values seen before 2007. Next slide, please. It's not just important for scientists to understand where there is sea ice cover, but we also want to track how thick it is. There's a variety of ways that this is done, but one of the easiest is that more or less how thick the ice is can be related to how old it is. So sea ice, which is several years old, will be thicker, less mobile, and more resilient to melting than seasonal ice, which is only formed during the most recent winter season. The two images shown display a comparison of sea ice age, one from 36 years ago, April 1985, with one from last April 2021. White regions show locations with the oldest, thickest sea ice, while those shown in dark blue indicate where there is only thin seasonal ice, less than 1 year old. By comparing how much more of the dark blue regions there are today than 36 years ago, we can get a sense of how much thinner the ice has become across much of the Arctic. Over the past decade, we've also been able to use new satellites to more directly measure ice thickness rather than relying on estimates of its age. These newer thickness measurements can be combined with information on ice extent to determine the volume or total amount of sea ice covering the Arctic Ocean. Importantly, these calculations reveal that the total amount of Arctic sea ice during April 2021 was the lowest in the available record. These reductions in both extent and volume of sea ice are indicative of the expected transition to a nearly entirely seasonal ice regime predicted to occur over the coming 30 years. This transition has already altered the timing of ice melt in many regions and will continue to do so with further warming, with important consequences for Arctic ecosystems and human activities. For example, many Arctic mammals require thick multi-year ice for seasonal habitats, and changing ice conditions will stress their survival. Phytoplankton are the foundation of the marine food chain, and their growth is affected by the timing of ice melt. The thinning and opening of Arctic waters will alter navigation and industry in the region, necessitating new international agreements. And of course, the Arctic's indigenous peoples have an inseparable tie to the ice, using it for both hunting and travel. And already, slower fall freeze-up can isolate communities and reduce food harvests. And occurrences such as these will grow more frequent with further warming. Next slide, please. Consistent with the dramatic changes in sea ice, we've also tracked persistent changes to seasonal snow conditions in the Arctic. The summer of 2020 saw the longest snow-free period across the Eurasian Arctic in 22 years of satellite data. A heat wave during spring caused record-breaking early snowmelt, and the warmest Arctic autumn in more than 100 years also delayed the onset of snow cover in the second half of the year. So the map on the screen shows how much longer or shorter the snow-free period was in 2020 compared to average. Brown shades are locations that had a longer snow-free period than normal. You can see that the majority of Arctic Eurasia, shown within the circle at the top of the map, had a longer snow-free period than average, in some regions up to 50% longer. Next slide, please. This past spring in 2021, we again saw near record lows of June snow extent over Eurasia and below normal conditions in North America as well. This is part of a very consistent long-term trend analogous to the changes we see in sea ice extent. June snow extent in the Eurasian Arctic has been below normal for 14 of the past 15 years, while over North America, June snow extent has been below normal for 15 consecutive years. Also analogous to sea ice, changes in seasonal snow cover have important consequences for the Arctic ecosystem. Early snowmelt is linked to increased potential for wildfire disturbance. And indeed, the past two summers, which saw record-breaking lows in June snow extent, subsequently saw wildfires ravage parts of Siberia during July and August. Early snowmelt is also associated with high midsummer tundra productivity, due in part to a longer snow-free growing period. 4 decades of satellite observations provide evidence of widespread tundra greening, as illustrated in the map on the left. In fact, the 5 highest measurements of midsummer tundra greenness have all occurred within the past 10 years. As highlighted already by my colleague Twila, these connected changes in sea ice, snow, vegetation, and related indicators are clear evidence that climate change has already arrived in the Arctic. Now I'd like to hand the presentation over to my colleague Gabriel Wolken to discuss glacier and permafrost hazards.
Thank you, Lawrence, for presenting the highlights of this year's Arctic report card. Hello, everyone. Again, my name is Gabriel Wolken. I'm a research professor at the University of Alaska Fairbanks and manager of the Climate and Catastrophe Hazards Program at the Alaska Division of Geological and Geophysical Surveys. I spent a lot of time exploring the cold, dynamic parts of our planet. And as a student, I was consumed with curiosity about glaciers and the drivers of climate that forced the changes on the landscape that I could trace with my footsteps. I've been studying glaciers, snow, and climate for more than 2 decades and have been reporting on the conditions of glaciers and ice caps outside Greenland in the Arctic Report Card for about half that time. Today, I'm here representing an international team of co-authors to present on the topic of hazards associated with climate-driven changes in Arctic glaciers and permafrost. Permafrost is land that has remained frozen for at least 2 consecutive years. About 5 million people live in the Northern Hemisphere's permafrost region, which includes glaciers. Retreating glaciers and thawing permafrost in this region are causing local to regional scale hazards that threaten people, infrastructure, and sustainable resource development. The acceleration in glacier mass loss and permafrost degradation is linked to Arctic surface air temperature increases that are twice the global average over the last 2 decades, and part of a positive warming trend in the Arctic that began around the mid-1960s. Much of the permafrost in the Arctic has been considered cold and stable, providing predictable habitat for plants and animals and land for development of infrastructure, villages, and even cities in some areas. But thawing of ice-rich permafrost can cause ground subsidence with negative implications for infrastructure, ecosystems, and human lives and livelihoods. Next slide, please. Permafrost degradation can threaten drinking water supplies in Arctic villages, and just the warming of permafrost can cause a reduction in its bearing capacity, impacting its ability to support structures. Next slide, please. This is particularly impactful in centers of high population and industrial economic activity, where human-induced permafrost degradation is exacerbating climatically driven changes in the permafrost system. Next slide. Mountain permafrost degradation can increase the likelihood of landslides. When these permafrost changes are coupled with slope destabilization from rapidly retreating glaciers, very large landslides can develop. Unstable, glaciarized mountain regions in Southeast Alaska have produced the landslides that have generated the tallest tsunamis in the world. And despite the remote location, these hazards threaten distant communities, marine traffic, and critical infrastructure. Glaciers and permafrost hazards occur along a spectrum of spatial, temporal, and intensity scales. Permafrost-related hazards are typically less severe, but impact many people across the Arctic. On the other hand, hazards associated with glaciers or changes in glaciers are more localized, abrupt, and most life-threatening. The largest disasters in terms of reach, damage, and lives lost that involve glaciers and permafrost occur typically through a combination or a chain of processes, each potentially representing a hazard by itself. For instance, slope failures and glacier detachments can trigger cascading hazards, especially when slope failures enter water bodies and cause outburst floods, debris flows, and tsunamis. These types of cascading hazards can present a risk to people and infrastructure at great distances from the initiating slope failure. Next slide, please. For example, the Kaare Fjord rock avalanche in 2017 generated a tsunami that traveled for more than 30 kilometers and killed 4 people in the village of Nuugaatsiaq, Greenland. Persistent unstable slope hazards in this area keep residents of Nuugaatsiaq from returning home. Next slide, please. Similarly, hazards in the Bering Fjord of Northwest Prince William Sound, Alaska, have prompted advisories of unsafe travel and possible tsunami inundation. These hazards are already having an impact on the local economy. These types of events highlight the need for broad-scale identification and assessment to improve our knowledge of glacier and permafrost hazards and to better inform stakeholder decision-making in the Arctic. To get there, we need more extensive baseline information. For example, maps of ground ice content and unstable slopes, developed from remote sensing, field-based observations, and community science or citizen science to identify hazards and evaluate potential landscape change for adaptation and mitigation planning. Next slide, please. We need to establish a network of long-term observation stations to begin to better understand conditions for mountain permafrost in the Arctic and refine understanding of how permafrost degradation and glacier retreat processes together impact slope stability so that we can better predict where large destructive hazards will occur. And we need to recognize that future efforts to address glaciers and permafrost hazards in the Arctic will require implementation of a co-production approach. For example, community members, scientists, and engineers working together to find effective adaptation preparedness options to enhance resilience in the Arctic. The great news here is that this is already happening at a grassroots level in some locations and in a more systematic fashion in others. As an international pan-Arctic community, we are fortunate to be able to learn from and work with one another to address these emerging glacier and permafrost-related hazards. I now want to introduce my colleague, Kaare Sikuaq Erickson, who will be speaking about COVID-19 and Alaska Native food access.
Koyana Gabriel. Thank you to the Arctic Report Card co-editors to allow us to highlight this specific subject that I'm going to talk about. My name is Kaare Sikuaq Erickson, and I'm from the Bering Sea village of Untitled in Western Alaska. And let me just first say that, our people, the stuff that you have seen today so far, our people live in these extremely variable conditions for thousands of years, and we're very, very worried about the changes that have been highlighted today. But in order to survive in this environment, we've had to have these kind of underlying characteristics of resiliency, sharing, respect, communal sharing, and some of that will come out in today's presentation. But it's really tough for us to live up there, but not, let alone thrive. But some of these underlying characteristics are some helpful reminders for maybe people that don't live in the Arctic, like relying on your neighbor, for instance. So today I'll be talking about an article that we contributed to the Arctic Report Card 2021 called "The Impacts of COVID-19 on Food Access for Alaska Natives." And this project was actually developed by the Indigenous Foods Knowledges Network, which I will refer to IFCN. And IFCN is a research coordination network funded through the National Science Foundation. Excuse me. This network brings together Indigenous communities and Indigenous knowledge focusing on food in the Arctic, subarctic, and Southwest USA, with support and coordination from researchers at the University of Colorado Boulder and University of Arizona. IFCN recognized the need to look at the situation that we were facing in the Arctic, in Alaska specifically, and applied for a rapid grant that was actually funded through the CARES Act. So they sought the funding, and then once they got the funding, and they developed a Indigenous Research Advisory Committee, which I'm a part of, and I'm very honored to be a part of it. And that was to help guide this project, the specific project that we're talking about here, which is, provides kind of a snapshot of some of the struggles that we were facing in 2020 specifically. We all know that this pandemic has kind of evolved in the last 2 years, but what I'm talking about today is specifically how the pandemic impacted food access in 2020. We interviewed many what we called experts, and those were people who maintain a close connection to their home communities and who were aware of how access to food was affected by the pandemic in 2020. So before we launch into some of the data findings that we had found out from our interviews with experts, I will provide a little bit of context just to help you understand the situation a little bit better here. First of all, why are Arctic communities more susceptible to pandemics? And I guess I'll backtrack, but I did want to mention that I recognize that, the Arctic Report Card really focuses on environmental observations, and this is kind of a little bit outside of that realm, but it is directly tied to the environment situation. So getting back to the context. Number one, why are Arctic communities more susceptible to pandemics? Well, we know that the communities are extremely remote and have, we have very, very limited access to healthcare. Each community will have a small clinic, maybe a couple of locals that are hired as health aides, but it can be days before you can see a doctor. And you have to travel, it's very expensive. So we have very limited access to healthcare locally. We also have limited infrastructure to actually live in. If you could imagine, I'm down here in New Orleans and people are trying to stay warm. If you could imagine trying to keep a big building, warm in the Arctic, it takes a lot to have extra space as well as limited resources to build. So you end up with kind of more crammed housing situations, and that could have an effect on health situations. And the situation of access to clean water as well in a lot of our villages is a very, very big issue that we've had for just forever. That we still have many villages in the US, up in Alaska, that people would consider living in third world conditions. For instance, Shishmaref community that I have a lot of family in, you literally have to wintertime, you have to drive by snow machine 5 to 7 miles to go to a frozen lake and hand chip the ice out to bring it back to town to have drinking water. If you could imagine how hard that would be on your living conditions, being able to sanitize yourself, being able to stay hydrated, it's really, really, really tough. And we're lucky that our people are very tough and very resilient, otherwise we would not have survived all these thousands of years, thrived. So, and then now I will talk briefly about the history of pandemics. This set the stage for how our communities really responded to this situation here, because if you don't know about the histories of pandemics in the Arctic, it's really, really a very, very dark history. We had huge losses. People call it the Great Deaths. In my village that I grew up in, we have an old site where kids are not allowed to go to because of the 1918 influenza epidemic, where it wiped out so much of our village that people still think that the flu is living in that old site there. So we're not allowed to even go around it. In a region alone in Bering Straits, in that one pandemic in 1919, 9 out of 12 communities lost 50% or more of their people, with Breivik Mission losing 90%, one of our villages in our region. So you could imagine how scary this was for our people who remember that history. So switching gears, I'll talk a little bit about the context of the food resources that we live off of in the Arctic. We tend to kind of categorize the food that we live off of into two sections. One being quote unquote store-bought, anything brought in by the cargo plane. So you're talking flour, sugar, chips, soda, anything you could think of that comes in that is sold in the local grocery stores. That's called store-bought food that we call it. And then we have the traditional foods, the subsistence foods that we live off of, which I'll talk more about. And the pandemic really impacted our reliance on it, impacted our access to store-bought food, but it really allowed us to fall back on that traditional food. The example that you see on the screen here is, we call it Inuit salad or Inupiaq salad. And this is a common dish across Alaska. And for instance, when I was eating a bowl of it, I realized how much it really shows how the wide variety of resources that we live off of, but also really represents these wide sharing networks. One little bowl of Inupiaq salad, when I was eating it, it had beluga muktuk, which was from an elder from St. Michael's that had given it to me after I helped them. It had dried ugaruk meat that was from my mother-in-law in Shishmaref. It had dungiak, which was blubber, also dried a little bit from Shishmaref. It had Sikuaq seal oil that was from my mom. It had smoked salmon fish that we had collected in interior Alaska. It had salmon eggs that we also collected that year. We had dried chum salmon, which was very rare from Inuktitut. It had herring eggs that was collected between Inuktitut and St. Michael. And it had cabbage, carrots, onions, pickles, potatoes, radish, and all those other vegetables. So that one little dish represents probably thousands of dollars invested into harvesting all these different resources, but it's really what's put together through these trading networks and And, so you also see the berries on the right, which is similar to, is kind of like our dessert that has all the different berries from the tundra. So I was able to provide a little bit of context here of why the communities are more susceptible, the dark history of pandemics, and and that really set the stage for how local indigenous people reacted to this pandemic. It was a very, very scary and continues to be scary for people. And then I also gave you an example of indigenous foods in the Arctic. So now I will go into talking briefly about some of the project findings. So our experts had shared, a lot of different challenges and also responsive solutions that they had faced in 2020. And today I'll be kind of focusing on one of the biggest issues that people faced across the state. Next slide, please. So, our communities really rely. I'm sorry. Here's a map showing the locations of the people that we had interviewed in Alaska and some of the villages and the main communities. And next slide, please. So today I'll briefly talk about one of the, like I said, one of the main things that people were very concerned of that really had a huge impact on people's lives. We really rely on these interregional and statewide airplane and cargo networks. Previous to the pandemic, the main airlines in our state, it served 115 communities with 72 small aircraft. And if you could imagine some of the distances on that map you see on the top right there, one of those flights from Anchorage to Dutch Harbor, for instance, is almost 800 miles. That's like from New Orleans all the way up to Virginia, for instance. So what happened was that in about a month into the pandemic, our Raven Air Group went bankrupt and just ceased to fly, and that caused huge issues for all the 115 villages that really relied on that lifeline. The daily flight from Anchorage, it brings in the medicines, it brings in the foods for the store. It gets people out. It gets sick people out, but it also allows us to have this interregional travel where people are traveling around to either collect resources from their traditional village or to trade resources as well. So when the airlines stopped, our store-bought food was basically all our shelves were just completely empty. We had to really fall back on really relying on our traditional foods and our sharing networks. So I think what happened there was that it really reminded us of probably one of our largest weaknesses is really relying on these cargo planes and these daily flights to Anchorage. But it also reminded us of our greatest strength, and that's our ability to fall back on our traditional foods and to be able to collect enough foods to share with our neighbors. And we really did fall back on that communal sharing and relations with others in our villages. You have to kind of put differences aside, in order to, because these are lifelong dependencies on our neighbors, so that's something that I think people can learn from throughout the U.S. and throughout the world in 2021. So that was kind of one of the main things that we had seen, was that the stoppage of all this travel, it really had a huge impact on our store shelves. And next slide, please. And access to actual subsistence infrastructure. So you saw the smokehouse on the previous slide, for instance. Like I'm in Anchorage most of the time, but I travel back to Untitled every fall to put away fish, because that's where I have access to a smokehouse. I have access to my parents' boats, and then I also have the traditional knowledge of where the fish is. And we also have a family spots, like fish camps and stuff. So you really have to be able to have that interregional and statewide travel for people to access the resources. I can't do that out of Anchorage if I don't have that infrastructure. So to end this presentation, I just wanted to really highlight that even though it's kind of a doom and gloom situation that we have seen from our scientists today, and they're sharing what they're seeing, that's truth there, and we really thank our science allies for getting that word out, because if it wasn't for you, it would be the world wouldn't know what we're facing. So really koyanok to our science allies. And I wanted to say that, to remind folks that our community is, we're human. We have babies, we have kids, we have young adults. It's really hard to kind of shove some of this negative doom and gloom down their throats. So what we have to always try to do is to provide them with a positive future, and to a hopeful and positive future. So even though working in these circles, it could be kind of draining sometimes. We also have to really try to provide a positive future to our youth and really uplift each other and ourselves as well. So having said that, I would like to say thank you very much to the taxpayers who actually paid for all the research that we're doing. Thank you to NSF for funding this project, for the IFKID network for coming up with the idea, my fellow research advisory committee folks, and also to the ARC 21 co-editors who allowed us to highlight this project, and finally, especially to the experts who had shared their knowledge with us. Thank you.
All right, a big thank you to our panelists. We're going to get started on the question and answer part of our presentation. Just a reminder to all the reporters, if you have a question, please put that into the Q&A box and we will get to you. Invite you to open your mic, or you may type your question in the box if you prefer. We're going to bring on a few more panelists for you, more folks from the Arctic Report Card who can answer questions specific to their area of expertise. So bear with us for a moment while we promote them to panelists and get their names for you in the chat there. Please feel free to start putting your questions there in the question and answer box. Okay, and we have a first question from Seth Bornstein at the Associated Press. Seth, we're going to go ahead and open your mic. One moment.
I am on mute.
Sorry, I think we were overlapping there. Apologies. Go ahead.
You can't hear me, right? Okay.
Yes, we can hear you, Seth. Go ahead.
I have two questions, one for Kaare and another one for Gabriel. For Kaare, aside from the COVID and the food issues, which was fascinating, when you go through what you call the doom and gloom here, from the sea ice to the permafrost to the glacial melt, beavers and all that, when it comes to the people living in the communities that you are at, which of these doom and gloom effects, as you call them, are hurting you the most, and in what ways? And for Gabriel, can you tell us if the permafrost thawing that you're seeing, is that accelerating? How would you characterize sort of the trend of permafrost thawing in the Arctic? Corey, I'm sorry, Corey.
Yeah, it's okay. Thank you, Seth. Yeah, I think it's all going to depend on the regional or the location, geographical location. When you look at the Arctic, it's really easy to start thinking that we all face a similar situation up there as indigenous people, but across the Arctic, it varies dramatically as far as geographical location of villages, as well as socioeconomic situation in each village too. In my specific region, I would say that the sea ice loss in the Bering Sea is extremely scary. It's really changing. It's changing the environment in the ocean. That cold, briny water that's formed when the ice is formed allows it's a ecosystem collapse situation. So I think the sea ice loss in my region is probably the biggest concern.
Thank you.
Yeah, and I can respond to your question. Yeah, so the thawing of permafrost is linked to the increase in air temperatures that we've seen, and permafrost temperatures have responded as well. And so there's been an increase in permafrost temperatures across the Arctic, so a pan-Arctic signal of permafrost temperature increase. And this has been documented across the Arctic in other ways as well, in terms of mapping of permafrost degradation, various subsidence issues, changes in ice wedges. So this temperature increase, permafrost thaw, the related physical degradation is noted across the Arctic in virtually every location, every land location in the circumpolar region.
In terms of a trend, is it, accelerating? Is it steady state? Is it, slow? I get, that's sort of what I'm looking for, not the location, but the speed of thawing.
Yeah, I think it's helpful to think about this in terms of the long-term changes. So the thawing of permafrost and the melting of land ice generally has been in place for millennia. And over the last several years, couple decades, in fact, those changes have been increasingly notable. And so there is an increase in acceleration in these changes across the Arctic.
Thank you.
Thank you, Seth. Our next question will be from Sarah Kaplan at the Washington Post. Sarah, we're going to open your mic and go ahead.
Hi, everyone. Thank you so much for this presentation. One of the themes that seems to be coming across in the report card and just in my reporting on the Arctic generally is this idea that because the Arctic is warming so fast, it's kind of it's a bit of I don't want to say omen, but it gives us a sense of what the future for the rest of the globe might look like, right? If the Arctic is already more than 2 degrees on average warmer than in the pre-industrial era, like that could be where the rest of the world is headed. And I'm curious, can you talk maybe, especially Kaare as someone who lives and knows this environment so deeply, but really anyone who has thoughts, can you talk about sort of what are seeing the way the Arctic is changing and some of these cascading effects, like what does this mean for people who live at lower latitudes? What could extreme change look like as the rest of the world kind of starts to warm on a scale that the Arctic has warmed?
Kaare, why don't you go ahead and start with that?
I'm not sure if I can answer that directly. Maybe that's more of a science question. We're talking about how the climate changes is impacting the southern latitudes. Was that the question?
Well, I guess, kind of from your experience of living in an environment that is changing so dramatically, are there lessons that you would give? You talked about the importance of community, but are there other lessons that you would give or kind of, insights that you think the people at lower latitudes need to learn from the ways that folks in the Arctic have had to adapt and respond to this kind of change?
Yeah, I think people need to put their differences aside and work together on things. The polarization of our society is not helping anything. And in the Arctic, we really do have to put things aside and focus on practical solutions. Otherwise, we won't survive. So I think the rest of the world is going to have to face that as well. Put differences aside and work together.
Sarah, would you like to hear from others? Perhaps I might ask if Matthew Druckenmiller, a fellow editor, has a perspective also from seeing the wide swath of information in this Arctic report card.
Sure, thank you, Twila. Well, I would say that the Arctic report card this year really touches upon disruptions across the Arctic system. And I think several of these examples that we address this year are reflective of vulnerabilities and change that we see across the globe. For example, the essay that Ken Tape has led on beavers expanded into the Arctic is a reminder of how species across the planet are on the move as climate warms. Gay's essay on marine pollution washing up in the Bering Strait is a reminder that plastic pollution globally in our oceans is a huge problem that climate changes in climate is a threat multiplier of. And then also, the essay by the essay on the changing marine soundscape by Kate Stafford is a reminder of the role that industrial noise, across our planet is having on ecosystems. And so I think that the vulnerabilities in the Arctic are more noticeable in today's world with the Arctic warming twice as fast as the rest of the globe. But these are similar vulnerabilities that we're going to see unfold for our entire planet in the decades to come.
All right, thank you. Our next question will be coming from Tim Gardner at Reuters. Tim, we're going to open your mic and give you an invitation to talk. Go ahead. I'm not hearing you too well. Can you try that again?
Hi, can you hear me now?
Yes, we can. Go ahead.
Okay, thank you. I just wanted to ask a very specific question. Some people may be surprised to read about the sort of the explosion of beavers in the region, and I wondered if someone could explain how that can lead to more melting of the permafrost.
Yeah, thanks for that question. And we have the lead author of that essay, Ken Tape. Why don't you address that?
Sure. Thanks for the question, Tim. So we mapped about 12,000 beaver ponds in Western Alaska. Most of those are new in the last 20 or 40 years. The idea is that when you cool water on the tundra surface, that water absorbs heat much more readily than the pre-existing tundra vegetation. So almost any time you cool water on the tundra, put a new pond in place, you're going to begin to rapidly thaw the permafrost surrounding it. So that's the idea. That's one of the primary concerns about this beaver colonization of the tundra that we're seeing in Western Alaska and very likely Northern Canada as well. And permafrost is just one impact. I think and Kaare could probably speak to this. Kaare's probably witnessed some of this influx in beavers around Unalakleet, but beavers impact all aspects of lowland ecosystems. Permafrost is obviously a key aspect of that, particularly because it stores a lot of carbon, but they also affect fish, boat access, water quality, a lot of different things. So it's a really big change, I think, to have them moving into the area. Kaare, if you have any observations, please add them.
Yeah, I think you can. Yeah, the beavers can have extreme dramatic impacts on the environment, raising up the water level. Just a couple observations that I've seen and learned about in my life is, for one, like sometimes the beavers around the tree areas, it'll create more of a moose habitat because it rises up the water level. So that's maybe kind of one good thing that we've noticed on some of the things, some of the impacts, but also like Ken said, it cuts off the fish as well. And I learned from scientists and elders in the Kotzebue region that when beavers move in, the beluga whales move out because they don't have quite the same access to all that fish that's coming out of the streams. And, you know, just I'll also add that across the board, there's kind of winners and losers in this whole climate change thing. And one of the positive things maybe with the greening of the Arctic, for instance, in the YK Delta, the Yukon-Kuskokwim Delta, you know, the vegetation has really taken off. You know, a lot of my friends down there, they say, well, when we were kids, it's just willows, and now we got trees. What happened is that the moose populations are just moving into that area very dramatically, where they have herds of moose pretty much. So that's a big new resource that people are living off of. So here and there are some winners and losers in this climate change thing. However, there are a lot more losers than winners right now, I think.
Thank you.
Jonathan Amos at the BBC had a follow-up on that beaver question. He's asking if someone can put numbers on the problem and if there's anything that can be done to control these populations and their impacts on the landscape.
And I'll send that back to you.
Okay, thanks, Twila. We're working on putting numbers on it. So, you know, mapping, we have a lot of beaver ponds to map. We've done a lot of Western Alaska, where our next step is to map beaver ponds in Northern Canada, and then also to see how they're changing in Northern Asia. So we don't really know at this point how, for example, the disturbance due to beavers stacks up versus the disturbances due to wildfire and tundra. That's a really big, prominent, and potentially sort of dangerous disturbance regime in the tundra. And we don't really know at this point how beaver disturbances will stack up against things like wildfire. So that's a great question, and I'm afraid we don't have a super clear answer at this point.
And would anyone like to follow up with the question about the control of beaver populations and their impact on landscape?
I will say that they're really pretty easy to catch as a subsistence hunter. And like, for instance, some of the rivers that we don't want them in, like Ikaaġun River or the Unalakleet, we could send a couple hunters up there to take care of them pretty fast. So if we could access them, so they're not too hard to catch, and they taste pretty good. They have good fur as well.
And something that might be noted in that essay, in areas that Ken Tape and others have looked at in the Alaska tundra, the instances of beaver ponds have doubled since 2000. And they also note in that essay that this is an instance where we cannot entirely pull apart the influence of climate change and also of practices in hunting or trapping. So all of these things are connected.
Our next question from Eilish Quinn, specialized reporter at Radio Canada International's Eye on the Arctic. This is for both scientists on the panel and for Corey. Do you think the general public outside of the North understands enough why they should care about the Arctic environmental change? And if so, what's missing from current scientific communication or journalistic coverage that's not bridging this gap?
Thank you for this question. I actually would be interested to hear from Rick Toman, another editor of the report card with that higher level view. I saw him on here earlier, although maybe, there he is.
Hi, thanks. So that is an excellent question. And unfortunately, I think at this point, there's no easy answer to this. I think it's really important that we continue to do what the Arctic Report Card has done over the last 16 years to document the changes. But as the Arctic Report Card has evolved, we're including the impacts to people. And I think that's really the connection that people at lower latitudes can make, that these changes are not abstract. It's not just about polar bears. It's about actual human beings, members of the world community that are being impacted now. Arctic communities are resilient. They've been through a lot over the last 10,000 years, and they'll continue to be. But the changes are impacting people. and their lives and livelihoods, from what's for dinner tonight on up to the, the international scale. So I think really, if we can stress anything, it's not just that it's warming by X degrees, but the impacts to actual people, I think, is the connection to make, so that people at lower latitudes fully understand what this means to people just like them.
This is Gabriel Wolken. I can just add to that a little bit too on the hazards aspect. There are global implications to the different changes in the Arctic, from perspective of changes in glaciers to degradation of permafrost. These rapid changes can have impacts on carbon release and sea level rise, and that's a global phenomenon. And so that's important to take into consideration. Locally, the emergence of these glacier and permafrost hazards can cause a disruption to shipping. And so in an era where there's increased concern about supplies and supply chain issues, travel through the Arctic, through the Northwest Passage is something that is receiving a lot more attention. Cryosphere-related hazards or changes in glaciers and permafrost can have significant impacts on the different transportation routes that are taken. And so large tsunamigenic or large landslides that cause tsunamis can have a significant impact on some of these shipping routes. And so that's another impact to people elsewhere on the globe from these changes in the Arctic.
Our next question is coming from Diana Hicker, the Nome Nugget newspaper in Nome, Alaska. She would like to ask Gay Sheffield about the marine debris washing ashore on their regional beaches and how the opening of potential shipping lanes might impact the ecosystem there further.
Well, thank you, Deanna, and thank you all. So we're in the Bering Strait region. I'm in Nome, Alaska, and the Bering Strait region is a transboundary area. So we share our waterway very closely with Chukotka in Russia. So Russia is our big neighbor. It's Alaska, Chukotka, Russia, US. Both countries have a different emphasis on their Arctic infrastructure. So Russia is in our mind, Russia is very advanced with their industrial shipping and their Northern Sea route and how they're underway. If you look right now, there are vessels using the Northern Sea route, and it's December. And the Bering Strait region, this is really something, if you've lived here, to see that. And these aren't small vessels, these are very large, 600 foot, 1,000 foot. And we also, between the two countries in this shared waterway, have different regulatory obligations or rules, federal regulatory rules for each country, and they're different. So we share and use the water in this narrow way, really separately. With the ice being reduced so much, we're seeing a lot more industrial traffic coming across from the Northern Sea route. And we're also seeing the Bering Sea fisheries fleet, especially on the Russian side, move northwards. This year, we had the very first commercial fishing in the Chukchi Sea ever. And that was on the Russian side. It is not something that is allowed in the United States to fish north of Diomede to Wales. So we do not commercially fish in the Chukchi Sea on our side. And now there is commercial fishing in the Chukchi Sea. So we have more and more traffic, more and more large traffic from people that, or from vessels that aren't from this region. We're seeing more, or we have seen more trash. What other problems with ecosystems? With trash, you can have entanglements. The animals can eat the plastics. And there were hazmats in that trash. So hazardous materials that are a problem for people. Anything that happens to people, marine wildlife in this region is not solely a conservation issue. It's a food security and human health and wildlife health issue. Other aspects of having large ship traffic could be, and I think some of the other panelists here could answer it. I think Kate Stafford has the noise soundscape and how that extra noise can maybe, I think it was in your video too, in the upset the animals' movements and so forth.
Would you like to, oh, go ahead.
I guess I would like to, one thing that really resonated with me was Corey's plea to work together. And that is truly how you live in the North, is by working together. And in the Bering Strait region, we do work together across the waterway as best we can, but we really need international communications to be much more frequent, relevant, and shared when you're talking about the Bering Strait region and a shared ecosystem, shared waterways, shared peoples. Thank you.
Kate Stafford, would you like to add any comment?
Sure, although I will second what Gay just said about working across borders, especially in the Bering Strait region. And what I've been working on is underwater sound as a pollution in the Arctic. And like with the plastic pollution, we are hearing increasing human use of the Arctic, increasing ship noise. In some regions, we're still hearing oil and gas development. And we're also hearing the sounds of countries using seismic air guns, which essentially listens to the ocean bottom to figure out where boundaries are in the Arctic now that it's not completely ice covered. For marine mammals, which use sound primarily, it's their primary modality. They use it to navigate, to find mates, to find food. They can change their acoustic behavior in the presence of human noise. They can potentially be deflected in the presence of very loud noise. And with the open water season, the season in which the Arctic is not covered with ice, increasing, we do have more commercial shipping, more tourism, more research vessels. But starting this year, in January 2021, there were actually 6 ice-strengthened liquid natural gas vessels that went through Anadyr Strait, so Bering Strait, but on the western side, up around the Northern Sea Route in January. So 2021 was unprecedented in terms of potential human impact with noise on the Arctic. And that's just going to continue. I believe they're going to encourage shipping year-round now across the Northern Sea Route.
Great, thanks, panel. Our next question is going to be from Evan Bush. Evan, we're going to invite you to open your mic. Go ahead when you're ready.
Hi, yeah, thanks so much. I'm wondering if you could talk a little bit more about projections for the rate of sea ice loss and at the point at which we'll have a seasonal a season without a sea ice, when that could be expected. I think you mentioned 30 years. Could we be a little more specific, or is that still unsettled?
Thanks for this question, Evan. I'm going to pass this to Walt Meyer, who's one of the lead authors for the sea ice essay. And Walt, if you wouldn't mind, everyone has a kind of a list of panelists, but if you wouldn't mind introducing yourself and then answering. Thanks.
Thanks, Twila. So yeah, I'm Walt Meyer at the National Snow and Ice Data Center, University of Colorado, and the lead author for the sea ice essay. Thanks for the question, Evan. And it's a difficult question, and it's really limited by the variability within the ice cover, the interannual variability, the weather that we get from year to year. So nailing it down to something more precise is really difficult. We're on a trajectory as temperatures continue to increase towards an ice-free, seasonally ice-free Arctic Ocean, but exactly what year is going to depend. It's probably going to come in an extreme year, a year that's particularly warm, even relative to the warming conditions, or particularly the winds are blowing in a particular direction to help clear out ice. So some of the model projections that have been published, and they show really an uncertainty of plus or minus a decade. And that's probably about the limit of what we can do. So I think the answer is we don't have a good exact number, but change is coming, and really as the report card shows, change is already here. We've lost most of the old ice already, and that's a fundamentally different environment. It's not like when we get to ice free, we're going to suddenly throw a switch and things are completely different. We're heading in that direction, and there's already big changes in the ice cover.
Thanks so much.
All right, well, we've come to the end of our question queue. Just give reporters a few more minutes if they have any final questions for our panelists.
Very briefly, I wanted to introduce Dr. Lydia Jennings, who was added a little bit later in the questions, but she was in the other room, and she's a co-author on the article as well as member of the IFCAN network. And she was in the room earlier to help answer the question about what people can learn outside of the Arctic, because as an indigenous perspective, she has a lot to offer there. Thank you, Lydia. And Nora is also a co-author.
Thank you, Carrie, and I'll just say hello briefly. I'm a member of the Pasquayaqui tribe, and I'm sure Carrie explained a bit that the IFCAN Indigenous Food Knowledge Network, we really look at the food challenges between the Arctic and the Southwest. And as a Southwest Indigenous person going up to the Arctic and learning how our decisions here in the Southwest really impact food access and climate issues in the Southwest has been a powerful movement or a powerful recognition. And so I know I missed the earlier question, but I just really wanted to add in through that work and learning how the pesticides that we spray here in the Southwest can concentrate and then go through the grasshopper effect, really impact the food quality and the overall health of our Arctic relatives is really something that the decisions that we make in these lower 48 continue to be challenges to our Arctic relatives, and really thinking about how we are part of a larger system and not isolated. And so I just really wanted to add that in. And thank you, Carrie, and everyone for allowing me to be here.
And a follow-up question from Diana Hicker. Moving forward, is the Arctic Report Card taken to policymakers to achieve global and concerted changes?
I wonder if Dr. Spinrad, if you would be interested in talking about the Arctic Report Card and how it helps decision makers.
Yeah, thank you, Twila. The short answer to the question is yes, of course. Not just NOAA, not just the other U.S. federal agencies, but in the global dialogue about policy, the report card is playing an ever increasingly important role in terms of framing policy. Policy obviously has to be framed around sound science, and we've counted on the report card for this for many years. I'd add to that I'm particularly encouraged right now because we've seen a resurgence, certainly within the U.S., of activity among the policymakers. We've seen the first meeting of the Arctic Executive Steering Committee through the State Department in many years, the Intergovernmental Arctic Research Policy Committee within the Office of Science and Technology Policy, which of course is the president's science advisor. All of these bodies, I could walk through the various activities, plans, engagements, and everything from navigation in the Arctic to fisheries in the Central Arctic to oil pollution management and marine litter. And so everyone, I can assure you that as I go into these meetings representing the interests and equities of the Department of Commerce, we take the report card as almost a Bible in terms of framing the scientific issues that need to be attended to. And one last point on that, I think that emphasis this time around on perspectives and incorporation of indigenous traditional ecological knowledge has been a critical and long needed component of that input into the scientific framing for policies. So hopefully in that short answer, you've gotten a sense that, excuse me, the diversity of policy applications, as well as both the internal US policy development and the international policy development.
Any more questions from our reporters? Well, since we have Lydia here and she did miss a few of the earlier questions, I thought I would read one of these back to you and give you an opportunity to answer if you're interested. This question came from Radio Canada International's Eye on the Arctic. Do you think the general public outside the North understands why they should care about Arctic environmental change? And if so, what's missing from current scientific communication or journalistic coverage that's not bridging this gap?
I think it's really easy for people to other the environment and the communities that are up there. And so I do think, you know, the incorporation of traditional ecological knowledge is really important, but also kind of teaching environmental change through this more systemic way of how it's having those direct impacts, I think are really important capacities of that. But how do we, you know, engage people to care about something that is so disassociated with them? And I think that's continuing to be a big challenge with science communication, and where and so I think that part of really relating it to the food systems as well as the climate systems is going to be an important part of that. And I think traditional ecological knowledge, as many people are continuing to learn about indigenous communities and how these knowledge systems have preceded colonial science methodologies, is a really important part of that. And so I know that's kind of a brief answer. I don't want to take up too much time, but I do think that is a great contribution that IFCN in showing these networks of similar challenges, but also similar solution building can be a very powerful connection to bring Arctic science and those ecosystems to and contextualize it to local communities. And so that's something that we definitely do through building relationships on the land with one another and through our knowledge systems that I think is really powerful.
Thank you, Lydia. Any final questions from our reporters? Any final comments from our panelists before we go? Well, I'd like to thank you all for attending. Big thanks to our panel for this wonderful presentation today. We'll have contact information for you if you would like to get in touch with any of them. And we will also have the video recording of this and the slides available to you following this event. Thank you all for coming. And over to Becca for final comment.
Yeah, I would just like to say, thank again our panelists for their time, all the reporters who were in the audience, and point out that our next press event starts shortly, in just half an hour at 11 a.m. Central Time, and it is a press conference on new discoveries from NASA's Parker Solar Probe as it approaches the sun. So hope to see some of you there. Thank you all.